So here we have pancreatic lipase. It's a pretty decently sized enzyme, 449 amino acids. And we can see that string of amino acids with their one-letter abbreviations here, starting at amino acid 1, and the numbers are on top there, and they go all the way to 449. So here's 446, 7, 8, and 9. So this is the enzyme that's going to be responsible for the triacylglycerol hydrolysis. Now, it's not the whole thing that's going to be involved, it's just a few of the amino acids. And those amino acids are going to be, there's 3 of them in particular. There's a histidine at position 263. So here's 266, 65, 64, 63. You see the one-letter abbreviation for histidine. And here you see it showing up. Maybe if we can visualize this a little bit better, if we show this as a wire, so we can get a better sense of where that histidine is on this enzyme. So histidine is 1. Serine at position 152 is going to be another 1. So here's 151, the serine right next to it, that's 152. Notice how when this protein folds, those amino acids are pretty close together. And then another one that is somewhat significant is the aspartic acid, or aspartate, at position 176. So that has the one-letter abbreviation of D. And notice that that is in that same position. So this is our active site for this pancreatic lipase enzyme that's going to be breaking their triacylglycerol apart. And it might be nice to visualize this with just the surface, so you can get a sense of what that active site looks like. So you can see that it's a pocket there, right? It's a pocket right in that area there. So let's move that back to the wire, and let's just look at those amino acids, those 3 amino acids, and visualize those. So we're going to hide everything that's unselected and just focus in on those 3 amino acids. So you have this histidine here, the serine here, and the aspartic acid here. It might be a little tricky to visualize with these lines, so let's actually revisualize them as spheres. Oops. And we can zoom to get a slightly better view of this. But if you notice here, this is the ring that is going to be stealing this hydrogen from the serine. This oxygen on the serine is going to be the nucleophile. So you can see how close they are. This is going to steal the hydrogen, gain a positive charge, and that positive charge is going to be stabilized by the negatively charged aspartic acid here. We can get maybe a slightly better sense about how this is fitting into the enzyme pocket if we select each of these, and then we can expand our view a little bit. I'm going to modify it. I'm going to expand by around 8 angstroms, well, let's say 5 angstroms. And now we can show those as wires. Oops. So these, and rezoom this. So this is our position here. Remember, our 3 amino acids of interest were 152, the serine there, the aspartic acid at 176, and then the histidine at 263. 263, this one right here. So we can take those and blow those up a little bit as spheres. So you can get a sense of how those are fitting into the amino acids around them. But hopefully that gives you somewhat of a visual sense of that enzyme pocket where the mechanism is going to happen as described in a separate video. This gives you a better sense of the enzyme pocket for the enzyme, this enzyme that is pancreatic lipase, that is wiggling around in your digestive tract, helping to break apart each of the triacylglycerols. One other molecule that's going to be important, that's going to interact with that pancreatic lipase, is of course going to be a triglyceride. This is what the big molecule that we get when we eat lipids. that needs to be broken down into 2 fatty acids and a monoacylglycerol before it passes into the mucosa of our duodenum. And so here you can see the glycerol backbone here. Each of these long chains is one of the fatty acids. We can visualize the charges on this molecule. Here, the green parts are non-polar. The red parts are slightly negative. The blue parts are slightly positive. So you can see that there. This is truly fatty with an acid on the end. And also, if you prefer, you can visualize this as van der Waals spheres. So these are all different ways of visualizing this triglyceride that is going to be important. That's going to be important in reacting with that pancreatic lipase in the hydrolysis of triacylglycerols.